We've been talking about electron configurations and what the electrons are doing in the atom. And we looked at something like this, and this represents the different orbitals that the electrons can occupy. And I gave you the somewhat crazy analogy of this being like a hotel, where this is the first floor and the second floor and the third floor and the fourth floor. And each of these letters indicates a room. So there's one room on the first floor and it's got one bed in it. There's two rooms on the second floor. The S room has one bed. The P room has three beds. On the third floor, there's three different rooms, S, P, and D. The D room has 5 beds. And yes, that would be kind of a silly hotel room.
Like a hostel?
Yeah, like a hostel or something. Yeah, exactly. Except you pay more to be in that room. It costs more, it's higher in energy, but it's quieter, I guess. I don't know. These analogies sometimes don't, they fall apart after a while. You can't take analogies too far. So this is asking us to write electron configurations and orbital diagrams for nitrogen, oxygen, fluorine, and neon. Let's do orbital diagrams first, because those are more like a picture. And so what I'm going to do is I'm going to kind of write these on top of each other. So here's 1s, and there's 2s, and here's 2p for the orbital diagram. And that's all we're going to need, actually. So for nitrogen, oh no, nitrogen seems more green to me. Not sure why. How many electrons does nitrogen have? 7, right? 7 electrons. And so to write the orbital diagram, we're going to start filling in these boxes. There's 1, 2, 3, 4, 5, 6, 7. And that would be the orbital diagram for nitrogen. These electrons are each going to take their own orbital because the energy level is the same, and they would prefer to spread out if they can. So we think of, if there's a room with 3 beds and I decided that maybe using Boy Scouts would be good. So the Boy Scouts are staying in this hostel. And there's these 3 Boy Scouts in one room with 3 beds. They're each going to take their own bed. It's just kind of a natural thing to do. And then this would be the orbital diagram. The electron configuration is more of a summary, a shorthand. And so we'd say 1s, and there's 2 electrons in that. And 2s, the 2s subshell has 2 electrons. And 2p has 3. And so there's 3 electrons there. If we add up the superscripts, 2 plus 2 is 4 plus 3 is 7. That's the total number of electrons. That can be kind of a check on your work. If those add up to the correct number, that's a good sign. How many electrons does oxygen have? 8. So it has 1 more electron. So in the orbital diagram, all we have to do is add 1 more electron. And so that one is now, if we add a 4th Boy Scout to this room, he's going to have to share a bed with somebody. And these are boys. And so they're going to sleep head to toe instead of, because, boys, these are Boy Scouts. They're not necessarily as big as grown-ups. And so if they sleep head to toe, it's much less like sleeping in the same bed. So that guy's going to go in there. And so for oxygen, the electron configuration, the beginning is always the same. 1s2, 2s2, 2p, and now there's 4. Fluorine. Let's make fluorine be orange. Fluorine has 9 electrons. So we just need to add 1 more. So if we're adding 1 more Boy Scout to that room, adding 1 more electron, he's going to go in right here. He's going to have to bunk with that guy. And so for fluorine, the electron configuration would be 1s2, 2s2, 2p, how many? 5. And then there's neon. Neon has 10. So that's going to add an electron in there. 1s2, 2s2, 2p6. The second principal energy level has two sublevels, two subshells, the S and the P. And for neon, that level is completely full. See that? It's completely full. There's nobody spilling over into the next higher level. It stops with a full shell. And that is an especially stable configuration for elements, which is one of the reasons that neon is a noble gas and doesn't make compounds. No one has been able to make a compound with neon yet. I'm sure there are several people who are trying very hard and writing grants and stuff to try to get money to do this for no practical purpose whatsoever. But that's one of the nice things about research. It doesn't necessarily have to be practical. So any questions about electron configurations and orbital diagrams? We can do a little bit of an abbreviation because, well, actually, let's go back here. Do you see how these all have some stuff in common? All of them start with 1s2, right? And once this gets full, they've all got that the same. And so instead of writing the whole thing, especially when we get to elements like xenon or something that have 54 electrons, it gets a little tedious. We have a bit of a shorthand or a shortcut, and we call this a noble gas configuration. So what we can do is put the symbol for the noble gas in brackets and use that as an abbreviation for the electron configuration of that noble gas. So let's look at sodium. How many electrons does sodium have?
11.
It has 11. Thank you. Yeah, if you answer, then everything goes faster and you'll get out of here sooner. Which would be a good thing, right? I think people are finally catching on to that. So sodium is going to have one more electron than neon. We just did neon. That was the electron configuration for neon. What's the next level? There's 1, 2, and 3. And the first subshell in that level is S, right? So there's S, and that one electron is going to go in there. So the noble gas shorthand is taking this, which is equal to the electron configuration for neon, and we write the element symbol neon in brackets. And then we just write the stuff that comes after it. And that saves us a lot of writing. Any questions? So when you're writing an electron configuration, you can use the noble gas shorthand. You're just going to look at the previous noble gas. Like here, if we were doing like strontium, here's strontium in period 5. Well, we're going to go up one period, period 4, and go all the way to the end. And we would start with krypton, and then there's just 2 extra electrons to write on top of that. Write electron configurations for each element. Aluminum. How many electrons does aluminum have?
13.
It's got 13. 13 electrons. And so there's different approaches to this. We haven't gotten to the beautiful periodic table part yet, but we're getting there. Let's do the noble gas shorthand on this one. What's the noble gas just before aluminum? Neon. So neon, and neon ended with 2p6, right? Neon has 10 electrons, aluminum has 13. We need 3 more here, and so we're going to fill up the 3s. We can put 2 electrons in there. Then the next level, not 3, is, it wasn't 2, it is 3. I wrote 2. Maybe I left my mind at home with my laptop charger. 3p1. That's aluminum. Bromine. How many electrons does bromine have? It's got more. So 35. Well, let's just do bromine the long way, just for grins. So we need to get up to 35. So first is the 1s, and that can hold 2. And then there's 2s, and then there's 2p. The p sublevels can hold 6. We're not even close, so I'm not going to count yet. And there's 3s, and that'll go 2, and 3p will be 6, and then 4s will be 2. And then we have to remember there's this orbital splitting. After 4s comes 3d. How many electrons can the d subshell hold? 10. Okay, now we might be getting close to 35, so let's count these. 10 and 10, there's 20, we're at 30. So we've got 5 more. What's after 3d? 4p. So it'll be 4p with 5 electrons. How about strontium?
38.
So 38 electrons. So that one's close to bromine, isn't it? What's the next noble gas over from bromine? The 36 electrons. Krypton, right? So krypton has 36 electrons. So if we do the noble gas shorthand for this one, we could put krypton in here. That would be end in 4p6, because it's 1 more than bromine, krypton is. And we need to go 2 electrons past that. What's after 4p? 5s. And so 5s, 2. And if you're counting up how many electrons, you'd say krypton has 36 plus 2 is 38. If you wrote that all out, it just gets tedious. That's the whole written out thing for strontium. Any questions? Oh, an orbital diagram for argon. Okay. So orbital diagrams are the boxes. So the first box is 1s, and then there's 2s, and then there's a triple box, it's 2p. Argon is bigger than the ones we've done, so we're going to have to make some more boxes here. You can kind of guess how many boxes you need and then count as you put the electrons in and see if you need more. Argon has 18 electrons. So we're going to put these in one at a time, up first and then down. So there's 2, 3, 4, 5, 6, 7. They're going to have their own orbital if they can. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Argon is also a noble gas. And argon's electron configuration fills up the highest level. The 3s and 3p are full. And that's a thing that all the other atoms are trying to get to. Any questions?